Chemical effects of electric current. Introduction to conducting property. Electric wires are used to conduct electricity in our homes. Do you know why electric wires are always coated with some plastic or rubber material? To protect us from the electric shock that an electric current may cause. Electric current can pass through some metals like aluminium, copper, brass, iron, silver, gold, etc. are known as conductors. Electric current cannot pass through some other materials like wood, plastic, rubber, glass, thermocol sheets, etc. are known as insulators. Most of the examples here are solid materials. What about liquids? Do liquids also conduct electricity? Let us learn more about it. Good and bad conducting liquids. Consider the circuit as shown on the screen. It is composed of battery, LED bulb, wire. Now take 5 different solutions: salt water, tap water, distilled water, lemon water, kerosene in different bowls. Let us see what happens when we switch on the battery knob in each case. Let us see tester circuit 1. When we switch on the battery knob in tester circuit 1, the light is emitted in a bulb because of the heating effect of current passing through its filament. A large current passing through the filament produces more heat and thus more intense light. Less intensity means that the current flowing through the bulb is weak or small in magnitude. So we can conclude that conducting power of solution in tester circuit 1 is good, as it is glowing brightly. So, salt solution is a good conductor of electricity. When we switch on the battery knob in tester circuit 2, LED bulb glows with a dim light. So we can conclude that conducting power of solution in tester circuit 2 is bad as it is glowing with dim light. So tap water is a poor conductor of electricity. When we switch on the battery knob in tester circuit 3, LED bulb is not glowing. So we can conclude that conducting power of solution in tester circuit 3 is very bad as it is not glowing. So, distilled water is a bad conductor of electricity. From above 3 cases, we can conclude that water conducts electricity depending upon the presence of salt content in it. When we switch on the battery knob in tester circuit 4, LED bulb glows with a bright light. So we can conclude that conducting power of solution in tester circuit 4 is good as it is glowing with bright light. So lemon juice is a good conductor of electricity. When we switch on the battery knob in tester circuit 5, LED bulb glows with a dim light. So we can conclude that conducting power of solution in tester circuit 5 is bad as it is glowing with dim light. So, kerosene is a poor conductor of electricity. We can classify different liquids as good or poor conductors depending upon the deflection in the magnetic compass when the free ends of wires were kept in various liquids. Did you know LED or light-emitting diode is an electronic device that produces light? LEDs can produce light of various colors such as green, yellow, red, blue, white, etc. Each LED is like a small bulb but without a filament. It requires a very small current to emit light. Each LED has two commenting terminals called its lead wires. The longer lead wire represents the positive terminal. In an electric circuit, it must always be connected to the positive terminal of the battery. LED lights are used in toys, as an indicator in electronic devices, in making decoration lights, in making torches, and in traffic signals. Let us summarize what we have learned. Electric current can pass through some metals like aluminium, copper, brass, iron, silver, gold, etc. are known as conductors. Electric current cannot pass through some materials like wood, plastic, rubber, glass, thermocol sheets, etc. are known as insulators. The light is emitted in a bulb because of the heating effect of current passing through its filament. A large current passing through the filament produces more heat and thus more light. Less intensity means that the current flowing through the bulb is weak or small in magnitude.